Time to introduce our second app of the course, which is going to be number 2, the Vectors app. And before I open it up, I just want to say this app is going to be very different in, spirit or something, nature. The SOHCAHTOA app, there were drills you had to do, and you had to get like 20 in a row right or 30 in a row right in order to pass the drill. This Vectors app does have quizzes, but they're just little 8-question multiple choice jobbies. And that's because the Vectors app really... It's like a calculator. It's like one of those online calculators you get where it's like, hey, how do I do this? And gives you the answer. So, all right, let me open this up and show you what I mean. So I'm going to open up app number 2, and I'm already logged in, so I'll proceed to app. Boom. Basic info for using the app. Yeah. You can read that if you need it. Math notes. You know, the math notes are not to replace the lecture notes, but if you've done the lecture already, it's worth reading through this because it kind of gives you a bit of a review, and you never know when you're going to pick up another little nugget, another little angle on something. That's how you get stuff to stick in there, is knowing things from different angles, different ways of saying it, and so on. Anyway, we got some math notes. Let me show you the first calculator. See where it says polar rect on the bottom center? Boink. So that symbol means it's a calculator, really. So what's this calculator do? It goes polar rect. It goes between polar form and rectangular form. So you'll see the 2 blue arrows, and you'll see the blue box. So the blue box says rectangular form, 330, 440. So the 330 is basically the x component, and the 440 is the y component. And the blue arrows represent the x component and the y component. Now, if you add those two up, you get the red vector. So the 2 blue vectors, if you list them side by side with this, v equals 330, 440, like that in the angle bracket thingies, that's called the rectangular form of a vector. But those are meant to represent the red vector. They're the same as the red. The 2 blues added together are the red vector, which you could just express that in polar form, and hence the pink box where it says 550 at an angle of 53 degrees. That would be the polar form of the vector. It's all the same vector. The blue vector, the 2 blue vectors are components. They add up to the red vector. You can express this red vector in polar form. You can express this red vector in rectangular form if you give 2 numbers. So anyway, like I say, this is just kind of like a online toy thing. You just I can take the R and I can drag it, and then boom, it'll update the X and Y components for you. So you see the numbers are changing for you, right? So I'm changing the R, and then boom, it updates. It even updates the scale on the XY axis sometimes. So you can change the theta around. Yep. Oh, there's your new components. There's a theta. Oh, there we go. And or I can come down here and I can say I'm going to change. Right now I'm moving the VX button, and because I'm moving the VX button, everything else is updating, the R, the theta. The only thing staying the same is V sub Y. So boom. Or I can play with the VY button. I can move it back and forth like this, changing the Y component of the vector, and everything else updates. Yep. Yeah, I like it up there. Okay. Or I can change, whatever. Notice if I change the R vector, it kind of has to wait until you're done before it'll update the blue vectors. Same with the theta. It's going to have to wait until you're done. That was just kind of an artifact of the way I programmed it. Of course, these text boxes means that if you want, you can also say, you know what, I really want the magnitude to be 47.4. That's really what I want. So return, boom, now it's got a 47.4, and it updates all your components for you. It's a neat little calculator, and it visualizes it for you. So this drill number 1 is going to be questions like that. Hey, I got a vector. That's polar form. What's the rectangular form? And so on. Adding vectors is like a second topic. In fact, I should say this drill is related to lesson 2.1, which is basically polar and rectangular forms of a vector. And then this is going to be related to lesson 2.3, actually, which is where we start adding vectors using the components method. So when you get to there, you'll really recognize what's going on here. So I got a blue arrow and I got a green arrow. So the blue arrow, I can change the blue arrow. I can change the X component of the blue arrow, and that changes. By the way, the blue arrow is one vector. The green arrow is another vector. The red arrow is what you get when you add the blue and the green arrows together. And notice you always have a parallelogram shape. No matter how I change, right now I'm changing the V sub Y, right? No matter how I change the X or Y components of these things, if you make a parallelogram out of using the green and the blue as 2 sides, then the diagonal across it, the red arrow, that would be the resultant, the answer. That's what you get when you add the blue and the green together. So down in the pink box, you can see it gives you the resultant both in rectangular form, 20.8, and in polar form, 79.375. Okay. So again, this is just a cute little calculator type thing, the kind of thing you might see on the web somewhere. I dare you to press that MI button someday. Anyway, drill number 2. Adding vectors, again, it's going to be a multiple choice kind of a thing. So when you're doing the quiz, feel free. You can say, add the vectors 3220 and negative 1840. Well, how am I going to do that? Well, I know. I'll go back here, and I'll make that say 32 and whatever the heck it was, right? Was it 3220? I can't even remember. It's probably 3220. So you can literally enter the vector here, hit return, take a look at it, say, ooh, that blue vector, I like it. It's a 3220 blue vector. I can dig it. And then you can go back to your drill and say, oh yeah, I'm also supposed to do negative 1840, so I'll do that for the green vector. And you get the idea. It'll show you, it's a calculator. It will show you the resultant in 2 forms. So this is kind of a toy around with it app. So I hope you enjoy it. It's a nice way to visualize what's happening with vectors, what's going on when I go changing my Vx, or when I go changing my R, or when I go changing my theta. What's going on to the other stuff? It'll show you. Or when I'm adding this vector to this vector, if I change the Y component of the green vector, or if I change the X component of the green vector, I can get all kinds of results here, right? Change this thing. Let's change this. Ooh, look at that. Now I've got that red arrow pointing southwest. That's really cool. Well, that's all there is to this one. Well, I hope you enjoy it. How do I turn this off?